are going to study about the data model. What do we mean by data model? Data model is a collection of concepts that can be used to describe the structure of a database, which provides a means to achieve data abstraction. If we look at the definition of data model, here we come across two terminologies, that is structure of a database and data abstraction. What do we mean by structure of a database? Structure of a database is nothing but the type of data that we are going to store in our database, the size of these data, and if there are any constraints that need to be imposed on these data. All these things together constitutes the structure of a database. Okay? Then what do we mean by data abstraction? Data abstraction is nothing but a technique with which we are going to provide the data in a way which different users perceive data. So, data abstraction is a technique with which we are going to provide data to different set of users in the way how they perceive data according to their knowledge or their requirement. Okay? So, we can call data model as a collection of concepts with which we can describe the structure of a database, thereby we can assure or achieve the data abstraction in our database. Now, after this we will move on to the next thing, that is categories of data model. So, the next is categories of data models. Based on different concepts, based on the concepts with which we are going to describe the database, there are plenty of data models in the field. So, with the available data model, we can categorize them into three categories. One is high level or conceptual data model. The next is low level or physical data model. Between these two, we have one more, that is representational data model. Okay? So, based on the concept with which the data model is being used, we are categorizing the data models into three categories, that is high level, low level and representational data model. What do we mean by high level data model or conceptual data model? As the name itself suggests, it is at a higher level. It does not actually gives more insights about the physical storage structure of a database. Here everything speaks in terms of entities, attributes, relationships, like this. Okay? This gives an overall picture of database to a set of users with which they can understand how exactly database looks like, how exactly database exists. Okay? But it does not give much insight about the physical storage of the database. The famous high level data model which we are using at current trend is ER model, ER data model. Here everything speaks in terms of entities, attributes, relationships. What do you mean by entities? Entity is nothing but an object or concept which is in a real world. Okay? An object or a concept in a real world constitutes entity. For example, a person, he can be an entity, right? And then customer, a project, company, many more. Here person, customer, project, company, all these things forms an example for entities, right? Then what about the attributes? Attribute is nothing but a special feature or a characteristic which defines our entity. For example, name of a person, which defines about person's identity, right? Customer ID, which defines about customer, project name, which defines about the project, and many more. So, entity is an object or concept in the real world, whereas attribute is a feature or characteristics with which we are going to explain about the entity, right. Next comes the relationship, which is nothing but an association between entities. Okay. Relationship is nothing but an association with entities, between two different entities. For example, we have a college entity, we have a student entity. There is an association between college and student, right? Student is part of college, right? So, such relationship or such association is called as relationship between different entities. So, this is about your ER data model, that is high level data model. Next comes the low level or physical model, data model, wherein more detail is given about the storage of database, how exactly the data is stored in the computer, in the main memory or secondary memory, what are the records that's been used, type of records and paths that are used. Okay. A very good example for path is an index. Okay. An index can be stored as an access path, which is going to give us the information about the location of record in the system. Okay. So, that is about the low level or physical data model. Then comes the representation data model, which falls in between these two categories. It does not give too much information about physical aspects, means that actual storage details of the database, and it is not superficial like entity relationship model. It lies in between these two. Okay. In representation data model, we have several other categories, types. I will show it. We have network model, we have hierarchical model, and we have relational database model. Okay. These are all the types of representational models, representational data models. We can also call representational data models as implementation data models. Okay. In the very first category, that is relational database model, everything will be in terms of two-dimensional tables. Okay. All the so-called entities are stored in terms of tables, and each table will have different set of values, right. Everything will be in terms of tables, and the relationship between two different entities can be established by having a common field. By having a common field in two different tables. Okay. Next comes the hierarchical model, wherein it follows a tree-like structure. One parent node will be there, under that many subnodes will be there. For example, if you consider a college database, we have a college database. Under college we have two different things, that is department, and one more is administration related thing. Then inside the department we have some more, like we have student details, we need to have staff details, and we need to have subject details, right. Once again, under subject we will have two things, that is either it can be theory or labs. So, this forms a tree like structure. It will have a one common root node, and then we have subsequent child nodes under this particular root node. So, this forms hierarchical data model. Then comes the network model, which can be called as an extension of hierarchical model, wherein we can have a graph like structure. For example, if we have entities like this, if you observe this, in hierarchical model we have one parent node followed by subsequent leaf nodes. Here the relationship is one to many. But here in network model it ends up as a graph-like structure wherein we can have more than one parent node. If you observe for an entity E, here we are having B and C as parent nodes. So, here the relationship is many to many, right. So, we can say the network model as an extension of hierarchical model where it is allowed to have more than one parent node, whereas in case of hierarchical model it is tree-like structure which begins with a root node and with subsequent child nodes. In relational database model, everything will be in terms of two-dimensional tables, okay, which will have rows and columns, and a common field is maintained in order to establish relationship between two different tables. So, to conclude, our data model based on the type or concepts which is being used in order to describe the database, we are going to categorize it into three main categories. The very first category is high level or conceptual data model. The second category is low level or physical data model. The third category is representational data model. Example for high level data model is entity relationship model, where everything speaks in terms of entities, attributes, relationships. Then comes the physical or low level data model, where it describes more about the physical storage aspects of the database, right. The records which is stored, the type of records, ordering of records, access paths to those records, all those things comes under physical level. Then comes the representational data model, which falls in between high level and low level data model, which don't give much exposure towards the actual storage of the data in the database, and it is not superficial as high level data model also. It lies in between those two. Under representational data model, we have three types, that is relational database model, network model and hierarchical model. Relational database model, everything in terms of 2D tables. Network model, it is in terms of graphical structure, graph-like structure, and hierarchical model gives us the tree structure, right. So, this is about database model. One more point, these representational data models speaks in terms of records, right. Everything speaks in terms of records. So, we also call this category of models as record based data models. Record based data models. So, this is about data models and categories of data models. The next concept which we are going to discuss is schemas, instances and database state. What do we mean by schemas? Schemas is nothing but the description of database during the phase of database design, okay. When we are going to design our database to meet the requirement of an application, what we are going to write, that is called as database schemas, okay. This description of database during the phase of database design is called as database schema, and once the database schema is defined, it is not going to change repeatedly, okay. It need to be finalized, okay. The graphical representation of schema is called as schema diagram, okay, or the diagrammatic representation of database schema is called as schema diagram. For example, if we have a student, he will be having his USN, name, his branch or course, his grade, etc., right. All these things all these information about the student need to be stored. So, we are writing the schema of student. So, this is called as the schema diagram of a student. Similarly, we can have for company, right? Company can have many details like company name, its registration number, its field of work, etc. right. So, these information about companies need to be stored in order to explain or describe company, right. So, this is called as schema, database schema diagram. Okay. Here each these object, student, company, like this, these are called as schema construct. Okay. The whole is called as schema diagram. Each of these object is called schema construct. Each of these data becomes the attributes of these particular entities or objects. Okay. So, this is about schema construct. Then comes database state or database snapshot. Okay. What do we mean by database snapshot? The data that is being stored in the database at a particular time is called as database snapshot. We can call database schema as the logical construct, whereas database snapshot as a physical existence or physical construct. Okay. Here database snapshot is can also be called as an instance of database. Okay. So, schema is a logical construct of a database, whereas database snapshot or instance can be called as a physical existence or construct of a database. This is the schema diagram which describes the database, means if student is the object which we are going to consider, then what are all the attributes or what are all the characteristics that we need to consider in order to explain student. If company is an object, what are all the attributes that we need to consider in order to explain the company. So, everything need to be thought, and it should be well documented during the phase of database design itself. It will not undergo many changes. If it undergoes changes to meet the requirement occasionally, then that is called as database evolution. Okay. So, what do we mean by database evolution? Database evolution is nothing but the modification that is being done to the schema of the database in order to meet the requirement of an application program, right. So, this is about our database schemas and instance and database state. Okay. Now, we will discuss about the three schema architecture of database. As the name itself suggests, the schema or the architecture of database is being divided into three schemas. One is external level, then internal level, then conceptual level. So, the database is being described in three different levels: external level, internal level, conceptual level. So, it will have several external views in the external level. Each external view will have an external schema. Okay. Each will have an external schema which describe the database in the way how that particular user group will perceive the data. Okay. In external level, we are going to have multiple external schema. Each external schema is going to define or describe a database in a way how that particular user group perceives the data. Then comes the conceptual level, which describes more about conceptual data model. It uses the data model which hides the information about physical storage of the database. It just gives an overview of how the data is being stored, and it emphasizes more on conceptual terms. Okay, that is the conceptual level scheme data model. Then comes the internal level or physical level, which makes use of physical data model. As we know, physical data model emphasizes more on the storage aspects of the database. Here, how records are being stored, how records are ordered in the database, how access path is being provided for each record which is stored in the database, everything will be described. So, the data structure of a database is defined in 3 different levels: external, internal and conceptual level, each with a clear separation between each other. Physical level describes more about physical aspects. This is actual storage space. Okay. Physical level explains more about physical storage of the data in the system, and conceptual data model at the conceptual level gives us the detailing more about conceptual terms, entities, relationships, data types, size of data type, constraints, etc. All those things are emphasized more, whereas physical aspects are not emphasized much. Thereby, a complete separation is maintained between the physical aspects and the conceptual aspects. Then comes the external view, where we are making use of external schema. Each external schema will have its own set of user groups. That means, for each set of user groups, a different external schema is being described, and each schema describes what exactly that particular user group is interested in. So, this is about 3 schema architecture. Okay. Here, when we say we have maintained a clear distinction or separation between 3 different levels of description of database, when a request is sent from an external view, then that need to be transformed into the conceptual level, and again that need to be transformed into the internal level, right. So, the method of transforming a request from an external level to a conceptual level is called as external conceptual mapping. Okay. It happens at this level. Here, the request that is being raised at external view is being transformed into the conceptual level, so that it is understood by the conceptual data model, right. So, that is called as external or conceptual mapping, and then from conceptual level that need to be transformed into a level or into a format which is understandable at internal level, that is at the physical storage level. So, that mapping is called as conceptual internal mapping. So, what do we know? What do we mean by mapping? Mapping is nothing but transforming a request or response between an external and conceptual level is called as external or conceptual mapping. A request or response that is transformed between conceptual to internal level is called as conceptual internal mapping. When we say that we are maintaining a 3 schema architecture, we need to transform a request from one level to another level, and that is done with the help of mapping, right. The next concept is the data independence. What do we mean by data independence? Data independence is the capacity, it is the capacity to modify schema at one level without affecting schema at higher level. So, what do we mean by data independence? Data independence can be termed as the capacity to modify schema at one level without affecting the schema at the next higher level. Here we come across two types of data independence. One is logical data independence and another is physical data independence. What do we mean by logical data independence? Logical data independence is nothing but modifying the schema at the conceptual level without affecting the schema at external level. So, that is called as logical data independence. The capacity to change the schema at internal level without affecting the schema at conceptual level is called as physical data independence. So, what do we mean by data independence? Data independence is nothing but the capacity to modify or change the schema at one level without affecting the schema at the next higher level. And we have two types of data independence explained here. One is logical and another is physical. Logical independence is one which states us that the change in conceptual level will not affect the external view. Similarly, the change at the internal level schema does not affect the functionality of the conceptual level schema. So far we have studied about the advantages of database management system over the traditional file processing system, and then we have studied about the architecture of database management system, right. We studied about 3 schema architecture where we are going to have 3 levels of schemas, each separated from the other, so that any modification done to a schema at one level should not be affected to the next higher level, right. Now, we have studied about architecture. Now, we need to know how to communicate with the database. In order to establish communication with the database, we need to have a language. As we all know, language is a medium of communication, right. In database, we have 4 different types of languages with which we can communicate. They are data definition language, storage definition language, view definition language and data manipulation language. What are these things? We will have a look at all these things one by one. Okay. Where there is a clear separation is maintained, that is a different levels are maintained, and like in 3 schema architecture, there we will use data definition language to specify conceptual schema. Okay. Where we have a clear separation, there we make use of data definition language to specify the conceptual schema of the database, and we use storage definition language to specify the internal level. Okay. This can either be called as physical schema. As you can remember, in 3 schema architecture we have physical or internal level at the lower level, and then after that we have a conceptual level, right. So, the lower level will be addressed by the storage definition language, whereas the conceptual level will be addressed by data definition language. When there is no clear separation is established in database, in such case data definition language itself will handle both the things, that is conceptual as well as internal level detailings will be specified using this DDL. Okay. So, now we have addressed 2 levels. If you remember, in 3 schema architecture we have one more level, right. We had several external views, right. Each view would be having a different external schema. In order to address that schema, we have a view definition language. View definition language will work on view level or external level. Right. So, in order to address the 3 levels, we have 3 different languages. Now, our database is ready. We have defined the schema for them. Conceptual, external as well as internal level schema is being addressed. Now, we need to have a language with which we can talk to the database, right. Data is being populated. In order to manipulate the data that is being stored in the database, we need to have one language, that is data manipulation language. Using this particular language, we are going to access the data that is being stored in the database. We can modify the data. You can add, edit, delete, etc. All these modification with respect to the data that is being stored in the database will be carried out with the help of data manipulation language. So, to conclude, we have 4 categories of languages in database. The very first one is data definition language, which describes us about the conceptual schema of the database. Then comes the storage definition language, which describes us the internal storage details. So, that is physical schema of the database. Then comes the view definition language, which addresses the different views that each external schema will have in our database, followed by the data manipulation language, which gives us the way through which we can have an access to the database. We can talk to the data which is being populated in the database, right. Now, we will move on to the next concept, that is database interfaces. So, what are these interfaces? As we all know, we have different set of user groups who acts as a consumer to our database. A single interface will not suffice the requirement of all these categories of users, right. So, in order to make them convenient to use the database, different interfaces have been designed. To name few, we will list it now. The very first interface is menu based. Menu based interface is designed, which will have menus and submenus option. As you might have observed, in various websites you will have menus, and if you click on those menus, submenus will appear. So, push down or pop up menus and submenus will be there, through which user can navigate, right. So, this is designed for mainly for web browsing. Okay, mainly for web browsing and mobile app users. Okay, these kind of interfaces are designed for such category of users. Then comes the next category of interface, that is form based interface. Okay, what do we have in form based interface? Here a form will be designed in which there will be several fields for which a user is going to input his details, right. Depending on the values which is inputted here, it is going to be generated, a query is going to be generated. This can be called as an interactive query. Okay. Using form based interface, a user is going to input his data, so he need not worry about writing queries. All that he need to do is he just need to type in whatever data that he need to input to the database. Okay. It is the job of the interface which it's going to convert it to an interactive query which is easily understandable by database. That is our second category of interface, that is form based interface. Next, the third category, that is graphical user interface. We call it as GUI. Okay. What it does here in GUI, the interface will be in terms of diagrams. Okay. Everything will be done in terms of diagrams. User need to manipulate these diagrams. What he need to do? He need to manipulate these diagrams in order to provide input to the database. Once again, here also user need not worry about how to write the query. It will be converted automatically to the query that is understandable by database management system. Okay. So, the user is going to manipulate the diagrams which is on the interface, and the request will be sent to the database. The next category of interfaces, natural language interface. Okay. What it will do? In case of natural language interface, user need not be aware of the exact format in which the data need to be given. He can give input in a common language like English, okay, any other common language. Okay. So, how it will work in natural language interface, there will be a dictionary or catalog kind of a thing, okay, which will match the predefined words which is there in the dictionary with the input that is being given by the user, right, and then it will be transformed to the form of query which is understandable by database. So, it is sufficient if user can input his data in the form of natural language, okay. That is our fourth category, that is natural language interface. Then comes the fifth category, that is speech input output. Speech input output interface. Here once again user need not be worried about the format in which the data need to be given. Here he not even need to input any data in terms of typing or something like that. It recognizes the speech here. So, once again here also we are going to have a dictionary kind of a thing where predefined words will be mapped to the respective query, okay, and the query will be formed with that. That is the speech input output interface. Then comes an interface that is designed for parametric users. What do we mean by parametric users? We have already seen that, right. Parametric user is nothing but a category of user who are going to make use of the same set of queries repeated times, only the input will vary, right. So, for such parametric users an interface will be designed so that it will have same functionality as buttons or something like that. If that particular user clicks on that button, that directly performs the operation required. For example, your banking transaction like account deposit, account withdrawal or balance inquiry, okay. If that particular user just click on this balance inquiry and enter the name of account or number of account, then he should be able to get the details of that particular account's balance, right. So, such interface is designed for parametric users. And then the last one, that is an interface that is being designed for database administrator. As we all know, database administrator will be having several privileged commands and he will be having several rights in order to manage our database, right. He should be allowed to create an account, right, delete an account and give an authorization based on the role and many more things. So, in order to perform all these functionalities, we need to create a separate interface for database administrator, because this interface cannot be shared by anyone else. He is the authorized person to have an access to such an interface where creation, deletion, authorization rights, all those things can be done by only database administrator, right. So, to conclude, we have listed 7 interfaces here. The very first one is menu based interface, where we have menus and submenus kind of things, and then form based interface where user is going to type in his input and it will be converted to a query. Next is graphical user interface, where user input data by manipulating the diagram that is there in the interface. Next is the natural language interface, where user is going to input the data in terms of the natural language that he knows, right. Next comes the speech input output interface, where speech is being considered as an input. Then the interface that is designed for parametric user, who is going to make use of the same query repeated times. So, this kind of interface will be designed for him. And then the interface for database administrator, where separate privileges for database administrators will be provided. So, this concludes our topic, that is database interfaces. Now, we will have a look at the next concept, that is database management system component modules. That means, what are the different components that is being made available in order to make the users or the consumers of database comfortable. Okay. Here we are addressing all categories of users. You can observe that we have addressed DBA, casual users, application programmers as well as parametric users. We have seen these categories of users already. For each categories of users, we have different flow in which that particular transaction will happen, right. The very first category that we are addressing is DBA staff, that is database administrator. Okay. What he does as database administrator is one who is going to create the database, he is going to manage the entire show in the database, right. So, he makes use of DDL statements, that is data definition language statements, and creates the schema for that particular database. Once he does that, it is going to be compiled using the DDL compiler, right. Compiler is going to check the correctness of the DDL statements that is being specified or done by the DBA, right. Once it is compiled, the database is created, the schema is created, and it is going to be stored in a catalog, in a disk, right. Those details about files, its size, its name, data which is being stored in that, and other details, all those things will be stored in system catalog, right. And DBA is also provided with several privileged commands, as we all know how he is going to provide authorization rights to different users. He is able to delete the records also. All those rights will be given to database administrator. So, that is also there, that flow is also there here. Next, we are addressing the casual users who are going to input their data in the form of menu based interface or form based interface. As we have already seen in our previous topics, we have different interfaces using which our casual users can input their data. Those data will be converted into an interactive query, right. The interactive query is then compiled for the validation of syntax and the type and name of the data that is being specified there. So, it will check, validate the interactive query which is being transformed from the menu based or different interfaces to this format, right. Once it is compiled, it is going to be optimized. The operations can be rearranged in order to improvise the efficiency. So, such optimization can be done with the help of catalog. Okay. Query optimizer interacts with the system catalog or the data dictionary which is stored in the disk, and it optimizes the query if any. Okay. Once it is done, it will be fed to the runtime database processor for further processing. Next comes the next category of user, that is application programmer. Application programmer will develop an application program using high definition languages, okay, like C, C++, Java, etc. Using high definition language, he is going to develop an application program. Along with high definition language, it also includes the queries also. Inside that it is embedded. So, pre-compiler is going to separate those database specific queries from the high definition language, that is C, C++, Java, like that. So, once after separating, it feeds the query database specific queries to DML compiler, where data manipulation language compiler will compile that and it will be sent to this portion. At this point, we need to get an input from host language compiler also. The remaining portion of the application program apart from query is being compiled at this portion at host language compiler, and the compiled version will be again merged and stored as a compiled transaction, or we can also call this as canned transaction, or we can call this as stored procedure, and this will be fed to a runtime database processor for further processing. Parametric user always works on the stored procedure with different input, right. Every time they will feed different input for the same set of procedures. So, he will directly come to this compiled transaction or canned transaction part. So, that will be fed to the runtime database processor for further processing. We will see how it will work. In the previous portion, we have seen the part A or the upper portion of the component module diagram, where we have discussed about the different set of users and the respective interfaces for them, and then feeding different queries to the system and how those queries will be compiled and fed to the runtime database processor. Now, we will have runtime database processor here. Here, if you look at this diagram, we have a runtime database processor, we have stored database with which runtime database processor will interact, and then we have stored data manager. What is the functionality or necessity of having stored data manager here? Actually, stored data manager is one who is going to maintain input output transactions between disk and main memory. Okay. So, different datas will be stored in the disk, right. Whenever we need to have an access to those data, a transaction need to be taken place between the disk and the main memory. There is a system which is already available, that is operating system. It is a functionality of operating system which will maintain the transaction between the disk and the main memory, but several times the buffer management becomes a headache. So, database management system itself is having its own subsystem, that is called as stored data manager, which is going to control the transaction between, that is input output operation between the disk and the main memory. Okay. That is the main functionality of stored data manager. Okay. Now, we have seen from 4 different categories of users, we have a feed to the runtime database processor. Runtime database processor will have an interaction with system catalog in order to take inputs whatever is required, okay, and it executes the query that is being generated, and if there is any data manipulation that need to be done to the database, that will be done. Okay. So, runtime data processor will have a interaction with system catalog and executes the query and does any modification that is required to the database. Okay. Along with this, there are other functionality like concurrency control, backup and recovery subsystem. Here we have maintained it as a separate submodule, but runtime database processor itself will does all these things. Okay. All these things will be done together. All these submodules or subsystems are provided as different components along with the database management system in order to take care of the transactions in the database. Okay. So, this is about database management system component modules. Now, we have seen different database component modules. Along with these component modules, there are some more utilities that is being provided. Okay. What are those utilities? We will list 4 utilities. Okay. The very first one is backup, second one is file loading, and third one is performance statistics, fourth one is storage reorganization. Okay. Here we are listing 4 utilities which are provided in database management system along with these components. Which are they? The very first one is backup. Why do we need backup? If there is any mishappenings happen during the catastrophic failures, if there is a software problem or hardware problem, at any such situation, we need to have a backup with which we can roll back to the previous state, right. So, backup utility is provided. Usually backup will be taken periodically from the database management system, and it will be stored in terms of files, in magnetic tapes, disk, something like that. Okay. So, this is one of the utility. Then loading files from different databases. Nowadays we are having several kinds or varieties of database management system. So, porting from one database to another is very common factor now. So, loading from files from one database to another database is also made available. So, auto transformation from one format to another format will also be possible here. The next utility is performance statistics. Performance statistics will be provided by monitoring the usage of the database to the database administrator. This will be provided to database administrator. With the help of statistics, database administrator will make a decision whether to reorganize the storage structure of the database, or if any new index need to be created or deleted in order to increase the performance of our database. The next point is storage reorganization. As we all know, every file, all those things will be stored in our system catalog, and indexing will be done, different paths will be there for each files, right. So, reordering of those files will help us to increase the efficiency many a times. So, that can be done with the storage reorganization utility. So, to conclude, we have 4 utilities provided by database management system: backup, loading, performance statistics and storage reorganization. Along with these utilities, there are many more utilities, but at present we have listed these 4 utilities. Now we will study about the classification of database management system. There are several criteria based on which we are going to classify the available database management system. We have listed 5 among them here. The very first one is data model, that is what are the types of data models that we are going to make use of. Based on that, we are going to classify the database management system. As we already know, there are plenty of data models available in the market, right. We have relational data model, right. Our SQL system works on relational data model. Similarly, we have object data model, where everything will be in terms of objects, right. Everything will be represented in terms of objects in case of object data model, but this is not being used frequently, extensively. But in case of relational data model, everything will be stored in terms of 2-dimensional tables, right, rows and columns, and we have attributes between 2 different tables. We establish relationship using a common field, right. So, that is about relational data model. Next comes object relational data model, which is an extended version of these 2, okay. And then we have hierarchical model, where we have tree like structure, right, and one-to-many relationship exists in case of hierarchical model, and many-to-many relationship exists in case of network model. We have already discussed about it when we are studying about the data models, right. These 2 models found in the legacy systems which we have, okay. Many legacy systems are still making use of these 2 kind of data models, and with the advent of technology, we have big data and NoSQL systems available, right. These systems makes use of plenty of varieties of data models. For example, key value based models, document based models, graph based models, column based models, and many more. In case of key value based model, it is almost similar to our hash table, right. Each value will be having a key assigned to it. So, with the help of key, we are able to retrieve the value that is being stored, right. This is a faster approach to approach the data. Next comes the document based, where every object will be stored in terms of document. Then comes the graph based model, where every object will be stored in terms of graphs, and the relationship between different objects will be done using, or will be represented using an arrow marked edges, right, with direction. Then column based. So, all these things comes under big data systems and NoSQL systems, and we introduced with XML system, where we are going to make use of tree structured data models, etc. So, tree structured data models are mainly used in case of commercial databases nowadays. So, this is about the first criteria based on which we are going to classify the database management system. Then comes the second criteria, that is number of users that a particular DBMS supports. Here we can categorize it into 2 systems, that is single user and multi-user. As the name itself suggests, single user systems are one where a single user is allowed to have an access to the database at a time. For example, we are having a database management system in our PC, right. It is a standalone software for us, right. Only a single user can have an access to that particular software. In case of multi-user systems, many users will have an access to the database concurrently, okay. That is about the second criteria, that is number of users that a particular DBMS supports. Next comes the third criteria, that is number of sites across which the DBMS is spread. There are 2 categories here. One is centralized and another is distributed. What do we mean by centralized? In case of centralized DBMS, the DBMS system or software is being installed and stored in a single system. Okay, it supports multiple users, but it will be stored in or saved in a single system. But in case of distributed, it will be spread across different systems which are connected through a network. Once again, here we come across two subcategories, that is homogeneous and heterogeneous. What do I mean by homogeneous? As name itself suggests, homogeneous means a same software, same database management software is being installed in all the system in the distributed concept. In case of heterogeneous system, different systems will have different database management system installed and they do interact. Okay, that is about the third criteria, that is number of sites among which the DBMS spreads. The next is cost. As we all know, different database management system will cost different, right? Free trials will be given for few days and then it will be asked to use, right? So, depending on the cost, we can find several DBMS, but there is no clear distinction here with respect to cost. And the last criteria is types of access path that is being given to files which are stored in the database management system. So, these are the 5 criteria based on which we are going to classify the database management system. Thank you.